Hello everybody. Today we are going to talk about experimental probability. So our goal today will be to determine the experimental probability of an event. Let's look at a few examples. So example 1. Talia and Yoshi plan for 1 out of 8 or 12.5% of the players winning a prize. During the school fair, they kept track of the numbers of total players and winners and recorded the data in the table below. How does the actual number of winners compare to the expected number of winners? Okay, so you see they did two trials here. 10 a.m. to noon, there were 213 total players and 22 winners. And then the next time, from noon to 2, there were 262 total players and 36 winners, for a total of 475 players and 58 winners. Okay? So to answer this question of, how does the actual data compare to what they expected it to be, first we can find the relative frequency of the data. So to do this, we put the number of times an event occurs over the total number of trials. So right here, 22 winners over 213 players. Now we would divide these, we would turn this fraction into a percent, and you get 10.3%. Okay, so that's the relative frequency of winners to total players in the first one. In the second one, 36 winners over 262 total players equals 13.7%. All right, in total, there were 58 winners over 475 total players. So the relative frequency of total winners over total players is 12.2%. Okay? So, again, relative frequency is the number of times an event occurs over the total number of trials, players, however you want to phrase it. All right, next up, we're going to find the experimental probability. Okay? Now, the experimental probability is actually the same thing as the relative frequency. Right? They're the same measure. So once you've found the relative frequency, you have found the experimental probability. Okay? So the theoretical probability, which is what they were expecting, was 12.5%. The actual data that came out, the actual experimental probability, was 12.2%. So we would say the experimental probability, what actually happened, was slightly lower than the theoretical probability, which is what we expected to happen. Okay? So the general idea right here. So what's the difference between theoretical and experimental probability? Theoretical probability is what we think will happen. That's what we studied in the last section in 7.2. Experimental probability is what actually happened. Okay? So theoretical is what we think is going to happen. Experimental is what actually happened. Let's take a look at this example down here. It says, during the second day of the school fair, Talia and Yoshi recorded 43 winners out of a total of 324 players. How does the actual number of winners compare to the expected number of winners? So again, their theoretical probability, what they expected was 1 winner out of every 8 players, or 12.5%. To find the experimental probability, we're going to find the relative frequency just like we did here. Okay? So, in this example, there were 43 winners out of a total of 324 players. So to figure out the relative frequency, or the experimental probability, we turn this number into a percent. And this gives you roughly 13.2%. So we would say that the relative frequency, or the experimental probability of this experiment, was 13.2%. Now, this is a little higher than their theoretical probability. So what this tells us is what actually happened is higher than what they expected to happen. So they had more winners than they thought they were going to. All right, so we use theoretical probability to try to predict what's going to happen, and then we use experimental probability to observe what did actually happen. Let's take a look at another example here. Joe Quinn also kept track of players and winners for his game during the fair. Based on the results shown in the table, how many winners should he expect if 300 people play his game? All right, so over here, this gives us all the data that we need. So if we look down here, it says all the players. So we're looking at total. So the relative frequency or experimental probability here is 17.1%. So 71 winners out of a total of 416 players. 71 over 416, that gets us 17.1% for his experimental probability. We can now use this information to estimate or predict how many people will win if 300 people play. So what we do is we combine information that we know. So we know that there were 71 winners out of a total of 416 players. And we can combine that with information that we don't know. So right here we have info we know. We know there's 71 winners out of 416 players. What we don't know is how many winners there would be if there were 300 players. So what we're going to do is we're going to set up a proportion. So what we know equals what we don't know. That's the proportion we're setting up. So 71 winners over 416 players is equal to, I'm not sure how many winners over 300 players. After we get it to this point, we can solve it algebraically. So we're going to get the winners alone. We're going to get the variable alone. It's being divided by 300, so we multiply by 300 on each side. All right, that gets rid of those 300s right there. And now we have our variable alone. And then when we do 300 times 71 over 416, we get 21,300 over 416. We simplify that by dividing, and we get about 51.2. So this tells us that we should expect about 51 winners in the game. Okay? If you guys have any questions or need any help, please either email me or wait until our conferences to talk about it. All right, I hope you guys do well on your assignment, and I will see you soon.